Good morning, second graders. How are you doing? Did you enjoy your Monday? Was the spelling practice clear? Thank you very much for having sent the homework, those who I have already checked. Those who haven't sent homework yet, remember you still have the chance to do it today in the afternoon, right? So guys, today is Tuesday, June the 9th, 2020, and as we usually have every single Tuesday, we will cover our science practice. Bear in mind that you can double check the contents of this practice either on your contract or on your Shake Up Science books, both student book and workbook, right? That being said, let's get started. These are the actual contract contents, okay? This is something that we have already studied on previous weeks, but we had to make this review before proceeding to finish. We are about to conclude the school year. Wow, amazing. So we had, for instance, on our contract, we had to match to complete the statements, and we had three options. Number 1 was Earth, number 2 was gravity, and number 3 was motion. So number 1, by definition, pulls objects down. What is that? Earth. In number 2, gravity is a force. And number 3, motion is the act of moving, like in this water fountain. You can always have this effect on a chocolate fountain, the ones that we usually have at parties, alright? Circle the correct words. This is something that we have already checked, but let's review. Gravity can, affirmative, pull objects without touching them. It's a non-contact force, okay? And gravity pulls objects down toward Earth. Now you might wonder, what happens with a kite? We see the girl flying the kite, and the kite is up in the air because of an unbalanced force, which is the air wind, okay? She keeps track of the movement of the kite because of the string she has attached to the framework of the kite. And then you might wonder, Miss, but why doesn't the kite fall down? Because of the action of an external force like the wind. The wind is blowing, and that's what keeps the kite flying up in the air. All of a sudden, there might be a change in the wind course, and probably the kite would fall down. Because of what? What do you think is the law that attracts this kite to the ground, Gabriel? Yeah, the law of gravity. Very good. Then we have to read and match. The wind holds the kite up. Obviously, was number 1, okay? And number 2, gravity pulls the water down. In the case of a water fountain, as we can tell. If we didn't have gravity, probably this water would remain up in the air, but it falls down again because of the action of gravity. Remember this. Ana Paula, hello, can you help me do the reading? Gravity pulls objects toward Earth unless something holds them up. Very good. Emilia, good morning. Can you help me? Gravity pulls on the kite. The wind holds up the kite, as we can see it here. Thank you. Ethan, hello. Can you do the reading? Gravity pulls on the roll of a string. The boy holds up the roll of a string. Well, this is not a boy but a girl, but it's exactly the same example that we have on the book. Let's check further contents. This is understanding the pull of gravity. Okay, we see the ball. It's bouncing. Repeat, bouncing. Why do you think the ball is bouncing, Said? Obviously because of an external force. Probably you were playing with Santino and you decided to throw the ball. Santino didn't catch it. Therefore, the ball is bouncing. But sooner or later, this will inevitably be attracted by the law of gravity, because we have a gravitational power and we have a pull of gravity. There are two major factors that determine the strength of an object's gravitational pull. Frida, good morning. Can you read the first one, please? Its mass, which can also be thought as how much matter it's made of or how easily it can be moved by a force. The sun has a big gravitational pull because it's so massive. What is massive? Enormous. You have almost no gravitational pull because you are so small. I'm not talking about you, Frida. I'm talking about all human beings. Man, women, mishkas, poodles, okay? And not made up of as much stuff compared to the earth and sun. Thank you, Frida. Is this clear? Remember the concepts of mass, matter, and weight, okay? Anyways, we're going to double check page 120 at the end. Jarexi, good morning. Can you read number 2? How close the things are together. Stars in other parts of the universe have almost no pull on us, but the sun has a huge pull because it is close. Now, what is pull? That capacity of attraction. We see, for instance, the sunlight with the sun, which is the biggest star of the solar system. We have the earth. Imagine the size of the earth compared to a person. We are very small compared to the earth, and much more if we are compared to sun. And see the moon. These are the forces of gravity. The weight of the person would be the same on earth and on the moon, but when it comes to its mass, it would be different, okay? This is understanding the pull of gravity. Now, let's see. You were supposed to complete this homework. The first one said, let's see, Francisco, good morning. Can you read number 1? You need to move your legs more to run faster, and this is true, as we can see here. In order to move faster, we need to bend and stretch, bend and stretch, bend and stretch, because the speed of the movement augmentates its motion, okay? Number 2, Camila, hello, good morning. You need less force to push a cart than a toy car. This is false, okay? You don't need less force to push a car than a toy car. It all depends on the object or the things that you have inside that cart. Obviously, we studied this example with a guy in the supermarket. He was on the student book. And we saw, for instance, that pushing the cart on a heavy content was more difficult than pushing an empty cart. In this case, we see the doggy. That doggo is pushing another doggo, which is almost the same size he is. So this is harder, but in general, you don't need more force. In number 3, let's see, Giselle. Hello. Can you read number 3? You need more force to pull a pony than a toy wagon. This is true, okay? You need more force to pull a pony because the pony is bigger. Remember, the more mass, the heavier the matter and the weight. And finally, number 4. Let's see, who can help me? Miguel, hello. Read number 4. You don't need more force to stop a swing. This is true. You don't need a force. In fact, if you stop moving, eventually the swing stops moving. It's because of your pulling, the pulling of your legs. Remember, stretch, bend, stretch, bend. That provokes the movement or the motion of the swing. But if you stop pushing and pulling, all of a sudden the swing is going to stop moving because you are exercising an external force on the object, okay? That is clear. Let's continue. Let's watch this video to summarize the contents. Remember, what did we study on this lesson? Who can tell me? Camila, do you remember? Marina? Does anybody remember? We study force. We study gravity, push, pull, zigzag, curved, lots of things. So let's see, this video contains most of the things that we have studied previously on this lesson, okay?
Force and motion. Wow.
So we have force and motion. We see an avalanche.
I'm okay.
How does an avalanche occur? What sets things in motion? What causes motion, and what stops it?
In general, the content.
Forces. A push, a stretch, a pitch, the attraction of a magnet, a touch, all these are forces.
By definition, a force is a push or a pull. And we saw all of these in the previous images of this video. Pushing the car, pulling a rope like in the tug of war, everything implies exercising some kind of force. And remember the two categories of forces, contact and non-contact forces.
A force is a push or attraction exercised by one object upon another. As the force of the wind on the blades of a windmill, the attraction between two magnets, an ox pulling a wagon, or your foot kicking a ball.
We have seen all these examples. We studied friction. We studied the differences between mass, matter, and weight. Everything is resumed here.
A force would not exist by itself because it is an interaction. What this means is that it depends on the relationship between various objects.
All the things that surround us exert forces on each other.
All the things that surround us exercise forces between each other. When you kick a ball, remember the example that I always gave you with Tadeo and his passion for playing soccer. Anytime Tadeo kicks the ball, there's some kind of friction. He's exercising a contact force and it creates a different kind of motion. The movement or the speed of its motion depends on the friction with the object. When we saw magnetism, when we saw the effect of attraction with magnets, obviously the opposites attract, but you need a metal. You need a metal in between. Because when you only have wood, it repels. It is not attracted. When we saw an ox pulling a wagon, obviously there is some kind of force. Is it contact or non-contact? It's a non-contact force most probably. Because of the pulling of the animal, there is motion in the wagon, okay? Obviously the speed, which is the rate, that is to say how fast or how slow it can go, will depend proportionally to the weight of the charge it has. In this case, it has, I don't know what that is. Probably those are vegetables, straw, different kinds of things, but it's heavy. Obviously, the heavier the mass, the slower the motion, okay? Because it is relative.
And this is constantly happening.
Some forces act in tiny things, such as those joining the water molecules to form a drop.
Remember, there's attraction between the molecules that form a drop of water.
Forces act on humongous things such as those governing the motion of the planets. Forces affect the shape and motion of all things.
Do you remember that? Forces affect the shape and motion of all things. The shape is the form and the motion is the movement, okay? Well guys, stay tuned. In the second and final part of this science practice, we will study the rest of this summary, because this is a summary of all the contents of this final lesson. You will have some exercises, some theoretical assumptions, and homework explanations. So guys, stay tuned. See you in part number 2 of this video. Mishka misses you, and so do I. Stay tuned.